What's up? What's up? It's your man, Jimmy Chan. All right, so we're given an equation and we got to find the domain and the range. The domain, fairly simple. Since there is no radicals and no fractions, that means my domain is going to be all reals, meaning negative infinity to positive infinity. All right? So how about for my range? Okay, so for my range, I need to look at this equation right here. Well, this equation is actually a quadratic, right? A quadratic equation. Or a quadratic function, you can call it that also. And better yet, if I look at this, I see that the a is negative. Since the a is negative, I know that I have a frowny face. Whoa. Now the frowny face means that I have a vertex, right? And that vertex is going to be a maximum. And it's going to go from the negative infinity, because those arrows are going to point towards negative infinity. I know it's from negative infinity to this vertex. All right. All right, great. So let's go ahead and find that vertex. And you're like, how? There's actually two ways, right? So you guys could actually do it as finding the axis of symmetry, because this is in standard form. So you can go with, so one way, I'll call it method A, would be to find the axis of symmetry first, right? Which is x is equal to negative b over 2a. And then plug that x into the equation and find your y value, okay? And then b would be to find your vertex, which is negative b over 2a for your x value, and then your y value will be f of negative b over 2a, right? So from there, you can find it that way if you want to. I am going to actually find it by converting this right here into the vertex form. So from standard form to a vertex form. To do so, what I want to do is take this equation here, and what I'm going to do is separate the first two from the last, because the last one is now in the doghouse. They made me mad. They're in the doghouse, but they're still in the same house. I don't want to kick them out of the house yet. They're just in the doghouse. When I look here, I want my x squared to have a coefficient of 1, so I actually have to do a GCF of negative 6 here. So my f of x, I'm going to pull a negative 6. So if I pull a negative 6 out, I'm now going to have an x squared, right, with a coefficient of 1. However, when I pull the negative 6 from the negative 2, I know it's going to be positive, but it's now going to be 1/3 x and then minus 11, okay? Because I'm not pulling the negative 6 from the 11, all right? So with that being said, I have to find a new c, and the c is equal to b divided by 2 squared, which is equal to my 1/3 here, divided by 2 squared, which this is going to equal to, what is this, 1/6. Squared, which is equal to 1/36. So I'm going to go ahead and add 1/36 here. Now, what do I have to do to balance that 1/36? So again, I look at this right here. Actually, that's not going to work. I got to do this. There we go. So that goes down, that goes here, that goes over here. Whoa, right? So when I multiply that, what do I get? Let's move this negative infinity over here. All right, so what do I get when I do that? Well, what I'm going to get is actually, what is that? Going to be a negative 1/6, right? Negative 1/6. So if that's going to be a negative 1/6, so this is going to be a negative 1/6. So that means I have to add 1/6 here to balance it out, because I want these two to become 0 so that I do not change the value of my equation. All right. Okay, with that being said, let's take a look. So now f of x is going to be -6. I need to now factor this, which it's already done. So that's going to be x plus 1/6 squared. And I hope that you guys see where the 1/6 came from. And then I got to do some math here. So let's take a look. Right, if I do the math here, what is 11 if I'm going to make it, or negative 11 over 1, have a denominator of 6? So that's going to have to be what? Negative 66 over 6, right? Because if I divide these two, it'll be negative 11, right? Awesome. Plus 1/6. Well, that looks like it's going to total up to be negative 65 over 6. All right. So now here I have my vertex. So if I compare this to f of x is equal to a times x minus h squared plus k, that means my vertex must be negative 1/6, comma, negative 65 over 6. So that means this right here is going to be my maximum point, my maximum y value. So that means my domain, so now I'm going to have to lower this over here and move this way here and point, and point that over here, because my range is right here. So what does that tell me about my range? Well, my range is going to go from negative infinity to negative 65 over 6. Actually, it's going to include it, because it's actually going to touch that point. So if I was to put it in another form, that means it's going to be, that means my y value is going to be less than or equal to 65 over 6. And that, ladies and gentlemen, is going to be choice C. I hope that helps. If there's any questions, please let me know. And it looks like that is very crowded there. So let me go ahead and do this and this. That means I gotta take all of that and bring it down a little bit. There we go. Now that looks a little nicer. That means I got a little bit more space here to box this. Ooh, hey. There we go. I hope that helps. Any questions? Let me know. See ya. Bye.